We are still on symmetric group and we have another question. Let alpha is equal to 1, 2, 3, 4, 3, 4, 2, 1 and beta is equal to 1, 2, 3, 4, 2, 4, 3, 1. Be the element of symmetric group of 4 letters. Compute alpha square and alpha inverse. Then find the order of alpha and beta. So let's compose alpha square. Alpha square is equal to alpha dot alpha, and as well you can see it's also known alpha composition alpha. So we can say alpha dot alpha will get what? Alpha square or alpha composition alpha. So it means that what our symmetric group of alpha 1, 2, 3, 4 S4 3, 4, 2, 1. Then another symmetric group of alpha 1, 2, 3, 4, 3, 4, 2, 1. Alpha dot alpha, that is alpha square. We have what? 1 is mapped to 3. 1 is mapped to 3. So 3 is mapped to 2. This is 2. 2 is mapped to 4. 2 is mapped to 4. 4 is mapped to 1. 3 is mapped to 2. 2 is mapped to 4. Then 4 is mapped to 1. 1 is mapped to 3. So it means alpha square, because 1 is mapped to 3. What do we have in 3? Under 3 we have 2. That's why we have 2 here. 2 is mapped to 4. We have to write our 2. Then under 2 here, what do we have? We have 4. We have to go to the 4. We have 1. That's why we have 1. 3 is mapped to 2. Under 2 we have what? We have 4. So that's why we have 4 here. 4 is mapped to 1. We have to go to 1 here. Under 1 we have 3. So it means we have complete alpha square. Then we want to find alpha inverse. How can we find alpha inverse? So for us to find alpha inverse, we have to what? We have to reverse the process of the mapping. So what's our alpha? What's our alpha first? We have alpha 1, 2, 3, 4. Then we have what? 3, 4, 2, 1. So we want to find alpha inverse of this. It means here 1 is mapped to 3 here. Alpha inverse. So 1 is mapped to 3 here. Let's test it like this. 1 is mapped to 3 here. 2 is mapped to 4. Then 3 is mapped to 2. Then 4 is mapped to 1. 4 is mapped to 1. So our alpha inverse will not be like the reverse process of this. So it will not be 3 is mapped to 1. 3 is mapped to 1. 4 is mapped to 2. 4 is mapped to 2. 2 is mapped to 3. 2 is mapped to 3. Then 1 is mapped to 4. Our alpha inverse will not be 1 is mapped to 4. We have what? We have 4. Because 1 comes first. So 2 is mapped to 3. So it means 2 is mapped to 3. We have 3. Then after 2 we have 3. 3 is mapped to 1. We have 1. Then 4 is mapped to 2. We have 2. So our alpha inverse is 4, 3, 1, 2. So alpha inverse is just like the reverse process of the mapping. Our alpha already is what? 1, 2, 3, 4. 3, 4, 2, 1. That is, our 1 is mapped to 3. Our 2 is mapped to 4. Our 3 is mapped to 2. Our 4 is mapped to 1. So we reverse process. That is, 3 will come here, 1 will go here. 4 will come here, 2 will go here. 3 will come here, 2 will go here. 4 will come here, 1 will come here. So that's why we now have, since 3 is mapped to 1 here, 4 is mapped to 2, 2 is mapped to 3, 1 is mapped to 4. So when 1 is mapped to 4 that come first, we have 4. After 1 is what? 2. When 2 is mapped to 3, since we have 2 next, 2 is mapped to 3, we have 3. After 2 we have what? 3. So 3 is mapped to 1, we have 1. After 3 we have 4. 4 is mapped to 2. So that's why we have 2. So our alpha inverse is what? 4, 3, 1, 2.